I'm going to be focusing on the panel side of WebVI, and we'll also focus on the diagram part of WebVI. And we're going to help you try and learn techniques to take your WebVIs to the next level. As it is kind of an advanced presentation, expect this to be a little rapid fire. You will follow everything we see here. You're not going to be able to see exactly what we click and all the things we type. But we wanted you to see what is possible with WebVIs. So even if you've never made a WebVI, I'm just curious, for the audience, who here has made a WebVI? Raise your hand. Quite a few people. Of those people, or maybe new people, do you also know JavaScript? All right, quite a few. Well, this is the best place for you. If you don't feel bad, because the people who raised their hands are going to write code for the people who didn't raise their hands, and we're all going to benefit. It's going to be beautiful. So, the best part about this is all the stuff we're going to fly through, we're going to put up on the web in GitHub, and you can see this after the fact. So you only need one link, only that one link, and you'll be able to get all the content we're going to share today, all the examples. You now want to run and play with some more. So, first, what did we talk about last year? Last year, we talked about what components are and how WebVIs fit into that picture. We went through CSS in lightning fast fashion. We talked about how to use Chrome DevTools to inspect your web page and what you can get out of that. How to update the HTML, raw HTML of your panel. And we talked about some things that weren't really available yet. JSLI, JavaScript, what does it exactly stand for? Interface. Anyhow, it was a teaser last year, and now it's real. Now you can play with it. It's in the product. It's productized, ready to go. And we built things on it and shipped in the product. We also talked about System Link Cloud. It's a cloud hosting alternative that was just an early access release, I believe, at the time, and now it's for real. You can use it, and it's available to you with your license. Pretty exciting. We have a video of this 2018 talk. If you ever want to go to catch up on that, you can do that. There's a QR code for that bit. Also, something about these slides in the upper right-hand corner, I put a little indicator about what version of NXG, when I'm showing on the content of the slide, this applies to. So in 2.1, you can do all this stuff. And I'm going to show things from 3.0 and 3.1 as well. And we'll try and be clear about what version we're talking about at a given time. All right, with all that disclaimer bit out of the way. So I'm going to start my part, talking about the panel. So I built just an example to kind of walk us through various things to improve. So this example you can build with NXG 2.1. I dropped some graphs. The idea here is that I have some kind of a heat source, and I'm monitoring that heat source and logging the temperature. I also have a tank full of coolant, and that goes up and down over time. I have some gauges, some buttons. I can also set some alarming and do some tracking and see when it goes over the alarm or not. So this is fine, there's nothing particularly wrong with it. Well, let's make it better. We can make it better. So to start with, if you take the edge of the browser and resize, we talked a lot today about resize already, but what happened is you start truncating the content. Okay? And that's not really how web pages work. That's how LabVIEW APIs maybe historically work. But we can do better on a WebVI. So we have this new feature called flexible layout. So you can take your panel and flip it into flexible layout mode, and then when you drop controls and indicators, you get little highlight indications on the things you hover through to position it relative to other things on the panel. So there's hotspots around. You kind of have to play with it a little bit, a little experimental, to get it just where you want it. To the right of the control, left of the control, sometimes on the bottom, and then if you get to the bottom of everything, you get a whole new row to put things into. And all these little boxes configure how everything shrinks and how it grows. So which box you pick matters, but it's easy to kind of try ones out and experiment and see until you get the result you want. So I applied that to this panel, and with that, then I now have some read-only text that kind of folds up on top of my graph. My graph gets a little smaller over time, and then my tank control kind of folds up underneath it. So if I'm on a device with a long, thin screen, like a mobile phone or a tablet, I kind of have a nice layout there. I'm just scrolling up and down. I'm not trying to do some weird 2D scrolling, which is not great. So we think this is a really exciting feature. There's still more we can do to augment this. Certain controls have the ability to stretch, some don't. You see my graph has a little bit of interesting shrinking behavior. You can actually configure that to either shrink or shrink horizontally only. But there are options there. And I expect we will add more options in subsequent versions. So I'm really excited about flexible layout. So also, not to be forgotten, is you can also just configure your controls. You select a control in NXG, and you have a right side configuration pane, and you can set things like fill colors, change the design of your controls. The gauge can be a needle, or it can be a fill thing, or just a little bar that moves up and down. Very flexible things in there, and text alignment. And we keep adding to this each release. I'm not going to outline each little button we add, but they're there. We're going to keep adding them there as time goes on. So please look for that before you reach for the more advanced tool. In 3.0, we added property nodes, which, yay, property nodes for your front panel, right? We got there. It's an important piece to be able to programmatically do things to your panel, and we know that, and now it's in the product. And there's even certain things you can only do from the property node. I think there's maybe only one. I highlighted the one. You can disable controls from the property node, and you can't do it in the configuration pane today. So this is a very good choice on how to style your panel. Use the property nodes when they're there. Always better to have programmatic control over a lot of the details of your control, so you have more flexible architectures going forward. So those are the easier things. Nothing advanced has really been covered yet. This is all easy peasy.
Are there any things in the panel pane that are not available on the property node?
Are there any things on the configuration pane not available in the property node? Yes, there are many things on the configuration pane not available in the property node. Although we are constantly trying to get them in sync. But for various reasons. Because reasons, it's hard. We're working on it. It just takes work, and we want to make sure we get as many property nodes as possible in as soon as possible. So this release 3.0 and 3.1, we really leaned hard on getting as many property nodes in as possible, and we're going to keep leaning on that lever as much as we can. All right, so let's say there's something else. You're like, that's great, you can do all those things, fantastic, didn't do what I wanted to do. Okay, well, there is an outlet. This is unlike some of the other places in LabVIEW. On the WebVI panel, we're backed by JavaScript and CSS, and you can kind of do whatever you can think of, whatever is possible with that web technology, which is quite a bit. So in this case, let's say I want to go to my string control, and I want to remove the border on that. We don't have a configuration pane setting, we don't have a property node. Am I SLL? No, you're not. Everything's fine, because you have CSS. How do you get CSS working? I'm going to demo this, but I'll kind of walk you through what I'm going to do first. You can go to your project, and you can add a new file. In this case, I just added a blank text file called style.css, and then you have to type in some CSS code. It's text code. That's a bummer, but just a little bit of text code. It's okay. We can write a little bit. I'll show you how I got this text code in the demo. In this case, I just refer to an object, and I tell it I want no border. The second thing I do is I have to go to my WebVI. I have to tell it, hey, I have a CSS file I want you to use. Can you please use this in addition to all the other stuff you're doing for me automatically? And that's pretty easy. You basically add a special tag. And I'll tell you where to get that special tag and where to put it as well. And then the last step is you have to go to your control. You have to tell it, somehow tag it. So that we say, hey, that style goes to that control. And that's pretty simple now. We've added a new configuration pane setting called HTML class attribute. In this case, I just added some dummy thing for my demo called it NIWeek-text. And then in my CSS code, I had to have this .NIWeek-text selector. Now, the only real hang up with it is pretty straightforward, except for you always have to remember this has no dot, and this has a dot, because this is technically a class, and that's okay. That's how you refer to classes in CSS. It's a minor thing. But, yes?
So in the style sheet there, you have the attribute with NIWeek-text and border, standard CSS property. So how do we know what are the potential properties that we can modify, and are they the standard CSS properties?
All right, so good question. So are these the standard CSS properties? It doesn't seem like NI border is a thing that's standard. You're right. And I didn't just guess it. So we're working on ways to document this. I'll share a preview of something I'm working on as a pet project. It's an FAQ we're going to put on GitHub in a week or two. It's not up there live yet, but I'll show you what it looks like in its current state, where we document some of the ones that we feel good about putting out there. There's a lot of CSS properties. Standard ones will probably work, but no guarantees, and if you go from version to version, I don't know if that will break, right? So the big disclaimer with the CSS styling is that when you upgrade versions, we may change the control technology, and that property might not work the way it used to. But in a given version, if you're frozen on one version, it's okay to use it, get your panel looking good, but just know that you're going to have to come back to this. It's going to be a little bit of a pain when you upgrade versions. I hope. Yeah, question, Ryan. Right, so the question is, how are we going to document this? You put in the release notes, etc. We're working that out. So it's basically expensive to maintain. We're trying to find a way to maintain it, give you the information you need, One thing we for sure want to capture is when we specifically break a property from one release to another release. I think release notes is a great suggestion. I should write that down. We should do that. Let's do that. All right, Ryan, we're doing it. This is a customer-driven company now. We're listening to the feedback. We'll do it today. It's great. Right now, I was planning just documenting this in this PDF sort of document on GitHub, and then having just each release having like a set of properties that we feel are stable enough. But there's some things that work, and you're like we don't even feel good about that in our own in-house project. So there's sometimes like some gradation about the quality of like how reliable it is. It'll work in all situations. Maybe the parts of your control don't work right. If there's little buttons, they screw up. There's like a lot of asterisks sometimes. Steve?
That property node breaking from version to version, will that mature and go away?
Oh, let me restate. It says the property node break from version to version. Property node is not going to break from version to version. The CSS text,
CSS.
that may break from version to version.
So would that get more mature and more stable over time, or is it?
We definitely don't like that.
Thank you. I agree.
But there's a lot of pieces and reasons why we're not doing it. One, it's expensive to try and track a fast-moving web technology, so we haven't figured out exactly how to do that. But once we get comfortable with a way to maintain this, we want to be able to say, hey, these are safe. You can use these every release, and then we'll slowly grow that set over time. We're just not quite there yet. This is still a pretty new product for us, and getting to that level of maturity, that's where we want to get. We're not there yet.
So, turn it back to the breaking portion. Does it break gracefully?
Does it break? What happens when it breaks? Does it break gracefully? So if I, in this case, wanted a border in say, an NXG 4.2, which is an imaginary release, I decided to make 1-NI border. That just means your rule won't work. So you'll have a border again, and you'll be like, WTF, why do I have this border? I have a rule specifically designed to remove the border. This is terrible. And then they'll say, no, you need to add the second, remove a dash. Another question, Daniel. Do you want to take this one more?
Good question.
Oh, okay, I'll repeat. So CSS is a fast-moving technology. Things are being added all the time. They just added Flexbox and some other new features to CSS. I think the answer is you can just keep using it. When your browser, the browsers you want support it, you can just use it in your WebVI.
And in terms of like first-class integration, so like the Flex layout system that's been added is built on top of Flexbox, and grid layouts are now more common in browsers. Will we use that to enable our layout system? It might come up in some aspects of it. So our goal with WebVIs is that we support the latest browsers, and the reason for that is because they have the newest set of features where you can rely on those native capabilities of the browser instead of trying to fake it yourself, and that helps your performance overall. And we're trying to performance is one of our biggest things for WebVIs. So that's why you might not actually see we don't have IE11 support or older browsers where we'd have to fake a bunch of things and we'd lose a lot of performance. That's not our goal.
So a lot of those pieces are
Yeah, our intention is as much that we can get driven by CSS, we're trying to do.
That's fine. Cool. And the end result is a string control with no border. Yay! All right, let's do it in real life now. Okay. So switch over to LabVIEW. So I have a version of that same panel here. And my first step is I need to make a CSS file, right? So the way I do that, without a mouse, I need a mouse. Okay. I'm going to locate my project in File Explorer where it's saved. And just for being a good citizen, I'm going to go ahead and make a folder called CSS, just to keep all my CSS together. You can put it anywhere you want. I'm going to make a new text file. All right, new text document. We'll call it style.css, because that helps later. I do like that extension. Fantastic. Okay, I open it up. It is awesome CSS. It is valid CSS. Is that correct, Milan? It feels valid. Looks good. All right. So if I refresh my project, I can show things that are on disk but not yet in my project. And now my CSS folder and my style thing is here. So I can now include that in my web component. I named it Playground because we're playing around in here. So I've added to my project. That was step one. Mission accomplished. Not quite. My CSS file still not that great. So I'm going to now pull up my styling FAQ that I referred to. Right now I have it in GitHub. I think we'll probably have it in GitHub. Ultimately, we just have to figure out exactly where and how to share it. But there's some basic things in here. It tells you a little about CSS. But the most important thing is at the bottom of the document where you say, hey, what properties are known to work in each version? So with 3.1, we know these things work, so we feel okay about recommending them. In this case, let's take the board on a Mac. So let's say I want to change the border. So I'm going to now just copy this little chunk of CSS and I'm going to put it in a text file. All right, and that's fine. And I'm going to change this user class name to something I like NIWeek.text. I'm lacking imagination right now. Okay, so that's my CSS file. Good to go. Not exactly. We still have 2 more steps, right? So the second step is telling this WebVI that that file even exists, so they can depend on it and use it. In 3.1, we moved the HTML access from it used to be here next to icon as a sort of like panel diagram icon HTML, and I moved it into a button, edit panel HTML, and the same keyboard shortcuts like find also work, which is fantastic. That was actually last NIWeek. We had a hands-on session, and everyone complained and freaked out. So we literally went back to the office the next week and implemented this feature. So, you know, your voice matters. All right. So here, turns out there's a special rule. How do I tell it about the CSS file? Well, I'm going to go back to my FAQ document, and up near the top, there's a bit about why is my WebVI ignoring my CSS? All right, so if I put a copy of the tag you want to put right in here, it's a link tag, you tell it it's a style sheet, and you tell it the path to the thing. Not rocket science, it's not so bad. We're not really doing hardcore HTML yet. You can paste that in here. It does need to go in the head section, maybe that's one thing that could be mistaken. Oh, actually it's already in there for some reason. No, I think I was practicing the demo earlier and I left a copy in there. Yeah, so the feedback was, it'd be cool if right-click import added it for you. I agree, that would be pretty cool. we should think about that. Oh, and look, and there I have to have done the third step already, which is tagging my control with NIWeek text, which is cool also. And now adding styles to other things is really straightforward. That is there. Okay, so I can go ahead and just pick off controls one by one and add this NIWeek-text attribute, and if I can type, I can border all of my things for the most part. How do you add multiple attributes? It turns out we have a space-delimited list, and if I wanted to add a second thing, like NIWeek background, let's call it, I can't type so much. Let's say I want to add more CSS that controls the background of objects. Okay, so I'm going to set that. And I come back to my CSS. I'm going to add a new thing called background. And I just need to know the rule to type in here. I have to know that I have a rule. Background. I think that one might work. No. Let's get the one for controls. Freeform text, numerics. Okay, let's have an indicator, so let's do this one. And I control indicator background color. These are pretty long and wordy, but let's, what color do y'all want? About goldenrod, I like that one. Sticks out. Say that. Okay, so now I come back, and nothing's goldenrod yet. That's a bummer. There's a trick here. You have to come to the source panel, and then if you just make any kind of edit and hit OK, it will go recalculate the CSS rules. So I come back here, now I get this like really, really amazing looking indicator that I really can't wait to get away from. All right, that's how multiple properties, and you can set those on multiple objects, build a whole like hierarchies of things to style all you want. Any questions on what I just showed you? Any questions on that?
If you're in the normal like current gen ID and message show MSG, but you just want to control it, just like edit the color of it and stuff like that. When you edit color of it, like the background, or some special NI background, NI border, you automatically add it to a CSS style sheet created and exists those properties.
Alright, cool. Well, that is an interesting idea. This file Alright. Moving back to slides. I believe I covered all the ground. Oh, I did
So
want
a lot of the things that are controlled by CSS styles, they actually are, like when you change them in the right rail, it does generate CSS for that. And you see it in the page. But the recommendation is anything that you can configure in the right rail in the diagram, do those. Those are the supported mechanisms. This is the escape hatch for everything else.
I just want to call this out. This is another thing that we did usability testing. We saw people struggling on how to get their WebVI actually running in a browser. So we added this new command called run in browser, right next to the run button. Go figure. So you click on that, and it does all the application building, goes to system designer, does the thing it needs to do, hits run, etc. And now you got your panel running. And if I was on the right tab, it would show me my hideous styling job. All right, instead of showing you really hideous styling, let me show you the finished deal. Sure, why not? Okay, so I have a different version of this in my project. I'm now going to just tell it to use this new version. And if I open that WebVI, this is a more professionally styled WebVI. And some interesting tricks I did here, besides just using the basic font controls and things to make things nice and put a colored background and drop shadows and stuff like that. There's a tab control around all this stuff. There's a 2-tab control. Very common, lots of tab controls in your panels, I imagine. What I did is I used a CSS rule to hide the tab carousel, and then used programmatic property node to switch the tab with those arrow buttons up top. So I can just kind of get rid of the tabs, not make it feel like a tab control, but now I have this kind of really awesome flexible container thing that I can use to style things. And yes, it works. As well as it works when there's no actual heat or tank coolant. So, yeah, this is stuff you can do. This is within reach. So,
Sizing and tabs work as well, and all that stuff.
the sizing and tabs work. I mean, in the sense of responsive layout, like this stuff works, which is pretty awesome. And there's like a little bit of touch control, but yeah, I mean, it's pretty good. All right, any questions? Not, I'll just kind of flash back and show you a little before and after bit. That's where we started, and that's after applying the CSS styling. And we made it responsive on the way, so super duper. Yeah, question?
Yeah, what about, you mentioned touch briefly, what about accessibility and using the keyboard to navigate between elements and various different viewpoints?
Right, so the question was about accessibility, navigating the keyboard, that sort of it.
Yeah, is that baked in? What sort of options have we got there?
So I know we need to eventually get to a place where we have tab order defined. I don't think we have it yet. So you can't define tab order, but that's obviously what we want. And then you can define how keyboard navigation through the panel would work. We're not there yet. In terms of localization and accessibility, we don't really have a lot going on yet.
That's the deal breaker for the last place I worked at.
Interesting. Well, why don't we talk later? I was going to learn some more about
Yeah.
what you experienced there, and then maybe we can get that in the next version.
Yay!
Well, I'm going to hand off to you. Here's the power stick.
All right. No. This. Hello? Is that working? All right. So where we started off, where Darin left us off, was the front panel changes, right? So these are the changes that have happened. This is the panel. These are the palettes in NXG 3.1. So the things that have changed, and Rita covered this really well recently, just before this, but in 2.1, we had, man, light blue and light green do not show up very well differently on here. But big things in 3.1, we added these button dialogues, we added the WebSocket APIs in 3.0, we added property nodes and events, which was really exciting. In 3.1, we added a couple more property nodes and events. So it's a high-level overview of what exists on the palette today. But there's another big feature we introduced in 3.0, added more in 3.1, and that's the JavaScript library interface. So what this does is it gives us the ability to execute JavaScript from the block diagram of our WebVI. It lets us leverage the browser and JS ecosystem. The browser has a bunch of built-in APIs. There's tons of libraries and controls available externally, so now you can call into them, have a way to do that. And more recently, we improved the patterns for sharing this. So once you've done it, once you've written a LabVIEW NXG library component that's using the JSLI to communicate with some JS file, now you can just copy and paste that into a new project and use it in a new application. So this is what the JSLI document looks like. In 3.1, so the original document in 3.0 was primarily this pane down here. So you had the ability to define the JavaScript function you want to execute. So here, this is a function available in the JavaScript browser context, console.log. This is the LabVIEW node name that you'll see on your diagram. And then you can configure the return value, so you only have one return value for a JavaScript function, and your different input values. And you can configure the types that you're inputting as well. In 3.1, we added the ability to manage those dependencies for you as well. So you have this JavaScript function you want to execute, but let's say it has an associated JS file and CSS file. You can put a little snippet in this top box that points to the style sheet, points to the JS file. If you have specific other attributes you need to add on to here besides just source, there's some reason for that in some applications. You can go ahead and add those. And these are linked to the files that are in your project. So when you build, it'll make sure that the paths are written out correctly in your build output. So the recommended steps for creating JSLIs, these are kind of Milan's recommended steps, my recommended steps, but I think it helps write good reusable code. So create a library component whenever you're creating a new JSLI. Create a library component versus an application component. The web app component is your main application. A library component will be for some reusable code. So make a library component that enables that copy and paste sharing. Add a support namespace in it to hide all the JS, JSLI, CSS stuff. The stuff that's not relevant to the public API for your library, but is all the internal implementation details. And part of that, I recommend don't export the JSLI document itself. So the JSLI document you saw on the previous slide, you have the ability to give the node a name, specify the input and output names, and that'll show up as a node on your diagram. But you don't want to have a whole lot of coupling between that JSLI document directly and a lot of external code. It's better to keep an API wrapper around it, so that way if you make changes to the underlying representation, it doesn't bleed out and you have to change a whole bunch of other code in your code base. And then create wrapper API functions. So create GVIs that call into these JSLI nodes. Gives you the ability to provide good docs, good icons. You could do pre and post processing. So if you have one return value that comes out of a JavaScript function, you actually want to parse it out and break it into multiple return values. If you have a wrapper VI already made, that makes it easier to do. And that simplifies future updates. Yeah, is there a
If
question?
that is the recommended path,
Yeah.
is that something on the docket to automate at least the creation of a wrapper per command? So scalability issue, right? Got 100 of them. You want to manually make 100 VIs that do pretty much the same thing. Thought? Yeah. Exactly, right?
Yeah. This is a recommendation. It also, you don't have to follow it, to be fair. But I think it makes, sure. So then if we're talking about having to deal with writing a large number of VIs that are wrapping JavaScript functions, we might want to look into more automation tools. And if you have examples of, we'd love to hear it. But all right, I'm stuck on it because we've talked, so no, I'm going to talk about it. So another thing to keep in mind is the idea, this comes from the web development area. It's this idea of polyfills. You don't have to read in too deep. The idea is when you're creating APIs for things that are kind of like filling in for other pieces, try and give it a similar API. If you're writing an API to do parsing of CSV files, try and make it like the desktop API already has. Maybe that'll be coming to the web platform. Maybe that'll be coming to WebVIs at some point in the future. If you already have something that's lined up with existing APIs, it'll be easier to adopt it and switch off that code you're maintaining yourself and switch into whatever's there natively. So it's just a concept from the web area. I wanted to bring it up, but it also seems pretty clear. If you're writing a new API and there's an existing API, try and use the same API, it makes for more reusable code. All right, so we're gonna go into a demo of how to set up a project using this recommendation. So grab a random NXG. I can click that home button to get back to the project dialog, and I'll make a new web application project. So my recommendation off the bat, whenever you're trying to make a new JSLI integration, is to start off with a library component. So here it'll be very excellently named library. I'm going to change the target to the web server target. That's something you kind of have to remember to do. Otherwise, you won't be able to call those nodes from your web application until you move it to the web server target. So in my library gcomp, I'm going to go ahead and create a namespace, support. And inside of there, I'll make a JavaScript library interface document. There's a bunch of helpful text in here that tells you how to find the CSS file that's in your project or JavaScript file that's in your project. Not going to need any of that. Specifically for this one, I'm going to call a built-in function console.log. So when I do console.log, it already configured the JavaScript global parameter. It has some clever algorithm to try and come up with a decent name. That's not too bad in this case. And I won't take a return value, but I need an input parameter. So I'll click add parameter. This will be the message. And I'll go ahead and make it a string. So I can pass in a string to this function. It'll invoke the console.log JavaScript function, and it won't return any value. All right, so then the recommendation, don't export the JSLI, but instead we're going to create our own GVI interface for this. So I'm going to make this log to console. This one is going to be pretty easy. I don't need any code to convert the inputs or outputs. It's going to be pretty much just the console log function, which actually is to show how to find it. If you click project items, software, library, so that's the name of my awesomely named library. Inside that support namespace, my also awesomely named JSLI document, also called library, has one log node inside of it. I hope that was completely unhelpful. So, I'm going to save that to the desktop. All right, I'm going to create inputs to that. And let me know if that was actually not helpful. But you can also search by name, so I know that name for that node was just log. So I can also just search for log, and I see with my unconfigured icon the same node. So that's a quicker way to find it. Cool. I'll wire up my inputs. And use it in my web application. So in my web application, you'll see I won't have the other log function exposed. Instead, I have my log to console. I should have it. Let me say diagram because it's a okay log to console. And I'm gonna not print that every 50 milliseconds. All right. So when I run that inside the editor, you're going to see not a lot of magic. So this is one thing to point out is the console log functions are helpful for debugging if you write one of these yourself. If you go to the tools launcher and click output, you can actually find the output window for where log messages are occurring. So that's available inside the editor. And if you ever get an error message, that pops up a dialog and says open the output window automatically. But if you want one of these more background log messages, that's how you find the output window. And then to find that in the browser as well, we're going to do run in browser. And the browser by default also doesn't show log messages, but if you right click on the page and choose inspect inside of Google Chrome, that'll bring up the Chrome DevTools. And in the window at the bottom, you can see the messages being printed out. All right, so we talked about how to make a library component, how to call into a JavaScript function. The big thing I want to point out next, though, is, and remember, that's for like find those people in the room who know JavaScript. You can reuse this in another project very easily. So if I go back and make a new web application, Now what I'm going to do is add a reference to that existing library component so I can go ahead and pull it in instantly. So I'm going to right click on my project, choose add file, save it to the desktop. I have that library component, pull that in, and it pulls in all the functions associated with that component, and now I can call that from my diagram. And I can't. All right. And I do this every time. Does anyone know why I did it? Why that didn't work? I imported it. It's right here in the links. What I had to do, and what I forget every single time I do this demo, no matter what, is it has to be on the web server target. So remember earlier when we did the file new, it asked us to put on the web server target. Here when you add it in, it didn't ask, it just put it on the desktop target. So you have to add it to the web server target. All right. And now, logged out. All right. If I run that, oh, that's not really fast. That's fine. Cool. Lots of logs. All right. Any questions? Yeah.
How would it work with JavaScript dependencies, like libraries like underscore JS or something like that?
Yeah. So that was so when you look at the library component over here. So that's what this section is for, the dependency section. So what you do is you add, like how Darin added his CSS file to his library, or to his project. If you add JS files to this project, then you can create the script tags you need to import it in. And whenever you use this node on a different web application, these script tags that you specify up here are going to get pulled in automatically. And those JS files and CSS files are included in your output.
Milan, yeah, going a step further, with Node and one of those massively highly dependent chains of JavaScript files, what's the roadmap that you want to handle bringing in a component that itself has its own JavaScript dependencies?
So right now it's I could show some examples later. I'll show you an example later, where I used an NPM dependency, but the idea is right now there's no, NXG doesn't have any knowledge of all those interlinked dependencies, so it's kind of install it top level inside of one component, and then only include inside of here the couple specific files you need. And the thing is, for a lot of front-end applications, they tend to have minified or built versions of the JS files in those projects, so you don't usually need the giant nested trees. That's just from my own experience though, but it's definitely case by case. And if you try and import that whole big node modules folder, I've seen like if you've used the NPM package manager, you probably shouldn't. The editor's not going to like it very much. So try and parse the log files.
So, because I've been bitten in the past by conflicting order in which you include the JavaScript files, which
Yes.
get into reasonably serious web apps. So obviously if you use something like browser file, job done.
Yeah.
So I was just thinking, this sounds like an area that
Yes.
some further
We have one escape hatch for that.
Yeah.
Actually, I don't remember how to get to it. Do you remember? Yeah.
You know the checkboxes?
I don't know the checkboxes.
I remember.
Okay. It will create that, so in your generated output, you'll see the list. So you'll have all the library components. They all have their JS dependencies. They'll get included in an order in the generated output, and you have the option to disable that. And then you can go into the source panel and manually add it yourself. And that's the only workaround we have at the moment. So it's not a great experience, but you have a way to okay, I need to manually enforce some ordering because I have lots and lots of dependencies that are coming in. And then we'd like to improve it in the future. And if you have use cases that you're running into, we want to hear about it for sure.
Probably explain a couple of things.
Yeah.
Cool, and then, so if I carry on, the next thing is version control kind of turns out to be kind of important in user interface stuff. So copy paste, great, but what about company-wide or community-wide
For sure.
management?
Yeah, so in NXG 3.1, we don't have the ability to, so our recommended approach is going to be take your library component and turn it into a NI package and share it that way. And that has the version management, you can publish to the store, all that stuff. In NXG 3.1, you can't actually do that yet. It's a technical issue with how the JS files are managed in the add-on state that we just need to work through. So you cannot publish these as NI packages yet. That's also not something exposed in NHT 3.1 yet either. So, but it will be coming. Or it should be. He can speak to that.
It's coming.
All right. All right.
Any day now.
Any other questions?
It's a slightly silly question, possibly, but being single-threaded, you run into performance issues if you don't complicate stuff. So sometimes it's nice to be able to get stuff out to a web worker. And obviously you could do that if you're doing it in your own JavaScript, but that's something we've got quite fancy stuff going on. In the NHT, is it possible to build a web worker? Split some of that off into a web worker?
That is, yeah, so the question was, if you're doing a lot of computation in your WebVI on your diagram, can you break some of it off into a web worker? Is that a good summary?
Yeah, that's good summary.
Not today. That's the answer. We'll see. So the underlying technology that we use, we compile out to a technology called WebAssembly. And WebAssembly doesn't have the ability to do threaded execution yet. So that's something that's blocking us from being able to provide that right now. All right, yeah. There's a lot of slides left, so we're gonna keep going. So now we're gonna actually get into some of the JSLI capabilities. So the number of types and the number of things that JSLI can call, that's JSLI supports, is fairly limited. So for JavaScript parameters and return values, you can do JavaScript Boolean, strings, numbers. You'll notice that int64 numbers aren't in this list. You can't actually represent int64 numbers safely in JavaScript. You have to essentially pass it through as a string and manipulate it that way. It's because of how JavaScript's number type is under the hood. That might be changing in the future, different story. And then you could also pass arrays of numbers as typed arrays. And this is one performance optimization we did to make sure when you get typed arrays out, that's a really fast operation from WebVIs, so it's useful if you're building up communication protocols. So we use that for implementing our WebSocket implementation that's in this series. You can only call global functions like normal JavaScript functions. For those who know more about it, the implication here is that we don't support the ability to load out of modules yet to depend on a module and be able to invoke something out of a module. It has to be something that's exposed globally that you can call into. And for async support, so this was added in 3.1, we have the ability to do promises / async await. So you can use async await and promises for asynchronous JavaScript execution. And we'll talk about what that means for other patterns for async execution. So we'll do another quick demo. So this is the power of what you can do with the JSLI after this presentation. All right. So here I have a web application. It has very simple things on it. So it has a text control in the top level panel with a CSS class I added and a button on it. So not a very exciting UI. And then I depend on two different components. So here's one that I wrapped a library called Uppy, and here's another one, eCharts. So one is a JavaScript charting package, one is a file selection package. So this VI itself doesn't have any JS or anything like that in it. It's just depending on existing components that do call into the JSLI and use the JSLI. So when I run this, I get, all right, relatively plain panel. If I click my giant little database button, it's calling into this Uppy library. So this Uppy library gives this awesome little GUI. It's a file selection utility. You can also configure it to do a webcam input, and it'll give you a little dialog to take a picture. So you can take a picture of something and upload the data from that onto your panel. So it's a pretty robust library. So I click Browse, go to the desktop, you can pick a JSON file. So this is all happening inside this Uppy library. It's executing right now. I can pick this JSON file. It looks like the right size. It gives a little file preview. If you have images, it actually shows a little image. It's really nice. I click Open. That goes onto the diagram, and then it passes it into a different control from the eCharts library. So this one is the surface plot library. So you can open some files and load it into this graph. So one thing to point out here is that there was no server communication involved here. This file was opened in the web browser running here inside the editor. That file was loaded onto my diagram. It wasn't sent to a server. And then from the diagram, I was able to process it and then show it in a different control. So what this looks like is right here. So the first part is this API configuration where I could pass in a whole bunch of parameters. So how do you pass in like array of string? Not one of the types you can pass in JSLI. So we'll see what that looks like. Here, that dialog pops up, and then this node blocks. These other things will run in the background. You can actually see it if you're looking really closely. You can see this chart running in parallel, initializing, while the user is selecting a file. So the user sits there, selects a file, gets annoyed, chooses a different file. They spend all their time doing it. So how do you wait? How do you block this node without blocking the rest of your diagram? And look at that. And then how do you do this pattern of, hey, I'm building up this object. I created this eCharts object, set a bunch of properties on it, invoked methods on it, but I can't pass JavaScript objects around. So how did I do that with the JSLI? And this last bit, I'm pulling in and referencing a control. In this case, I'm using a class selector because I can't use a control reference directly. So what does that pattern look like? So we're going to fly through these really quick. All right. All right. So that same diagram, four different things that we want to figure out. How do we accomplish that with the JSLI? Multiple properties, waiting for asynchronous actions, front panel visuals, and manipulating objects. So I'm going to go very high level with this, and the key is go to the GitHub pages after. This is where all these little patterns and code snippets are going to be available. So for passing multiple properties, a high level idea, bundle it up into something that can be used in the flattened to JSON node. So then on the WebVI side, you're using flattened and unflattened from JSON. And then on the JS side, you're using JSON.parse and JSON.stringify. So you're using the browser's functions to parse JSON and WebVI's functions to parse and create JSON. The benefit here is that you're not coming up with your own serialization mechanism. You're not going to run into problems with, oh, you added extra commas because you made it CSV, you made it a text file. WebVIs and JavaScript both understand this JSON format, so you can use that really easily to make a structure to pass between them. So that's the high-level recommendation. For creating and manipulating objects, so you need something that will, so for example, on this, on the left-hand side here, so it says create object, it's going to return a reference to an object, and use object is going to take that reference, find that object, and manipulate it. So there's not a great built-in mechanism for this yet, but what you could do right now is you could bring in, it says, you could bring in a little snippet of code. So I'm going to put a little snippet online called the reference manager, and what that does is you can use that to create a reference, it'll return a number, you can pass the number back to your diagram, pass it to a different function, it can look up that number, and then get a reference to the object you want to manipulate. Clear as mud? All right. So in the end, there's these three methods on it. Create reference, get object, close reference, create object. So we'll say create this reference for some awesome object I'm making in JavaScript, and then use, I pass that number in, do some good error handling, and then use it. So the next pattern, waiting for asynchronous actions. So as I mentioned in 3.1, we actually support promises and async await directly. So you have these three nodes, waits for thing 1, waits for thing 2, waits for thing 3. So waits for thing 1, if I have an async function, the editor will figure it out and it'll know how to handle it. So if my JavaScript function is just an async function, it'll know how to wait for it until it's done running to continue that node. If I have waits for thing 2 and it returns some promise, so it invokes a function that creates a promise and I return that promise, then the editor understands it. And that's because these are kind of largely under the hood, very similar patterns. Another big one that we don't support directly is callback-based asynchronous code. So if you have something that needs a callback function, so here I have some callback thing. When I run it, it takes a callback function that needs to execute in the future. What I have to do instead is wrap it in a promise and then use the promises functions to interface with that callback. So it's not super clean. It's not as easy as it could be. But the thing here is that callbacks and callback behavior is not really a standard JavaScript feature. There's different patterns for it. Some switch the order of these. Some make two separate functions. So the goal is that we stuck with something that is very well standardized, this promise behavior, that is a common JavaScript thing. So if you need to figure out how does my library, how can I convert this library to be promises, you're going to find lots of documentation on it. So we stuck with the thing that is well specified, well standardized, and then you can interface with that for other libraries. Yeah, it's great. All right. So for front panel visuals, this breaks down in 3 parts. I know this is like slamming really hard, really fast, bunch of random JavaScript. Main goal, keep that link, reference it later. Just be aware of the kinds of problems that exist and that there are solutions, and then tell us more problems you run into so we can have more solutions. So for the front panel visuals, the first thing you do, create a UI component. So here we have that placeholder text component. Just use the editor, set its size, set its width. Then add a class to it. So here we select that placeholder. We add a class in the configuration pane, my-placeholder. Remember here, when you're specifying the class name, you don't put the dot in front of it, but the selector, whenever you use it on the diagram, you use it in a CSS file, you need the dot in that string at that point. So then on the diagram, what it looks like, you take the string, make sure you put that dot on it, so the dot my placeholder, pass it into your function, and then this is the snippet you could use to go get that placeholder, delete its contents inside, and then create your own thing, make it the full width and height of that placeholder, so it uses the same height, and dump it into the page. So again, it's more about, can I replace the visual? Yes, and then you can find the snippet online. All right, so I want to show one more demo using these techniques. Do I have time for that? No, we'll see. All right, so this is a little Bluetooth thing. Oh, do we not have time for this?
To and on 6th Street.
Yeah, right.
Turn that light off.
Okay.
Last call.
Did that turn on the lights? I don't think so. All right, so we have a little awesome little Bluetooth jigger there. Ignore the default image, I couldn't get rid of it, my brother said it. So, I have this other little web application. It's really hard to see with the lights on. Thank you. So what I'm gonna do, click this connect to Dotty button. I need to turn on Bluetooth on my laptop, and it's gonna give me a hot topic instead of doing it and break my Dotty. Hold on. And I'm gonna turn on Bluetooth. So I have a little Bluetooth thing. I'm gonna refresh this page. Connect to Dotty. All right, find the device, pair to it. Connecting. Okay. Connected. So now this WebVI running completely locally, not talking through the web or anything, from Bluetooth, from this laptop in the browser that's running to that device, can control it very slowly in this room. Yeah! I can set it to 3. Yeah! All right, so that's just showing so this library, the Web Bluetooth API, standard library built into Chrome, using the JSLI and a lot of these techniques from this host, I'm able to interface with that library, control hardware from a WebVI. Sweet. All right. Thank you. Cool. So, one last thing. We've been talking about the JSLI as this interface to the JavaScript that's running in your browser. But WebVIs are built JavaScript, HTML, CSS applications. They don't have any other dependency. They are a little standalone piece of JavaScript code, and you can run them in different JavaScript host environments. There's nothing that stops that from happening. So yeah, we've been talking about the browser, but what other JavaScript host environments are there? And how can you can now talk to them, to your surrounding host environment from the JSLI. So this is one. Excel has an add-on tool you can make, so you can make your own little add-ons, and it exposes JavaScript functions for manipulating the cells on the spreadsheet. I clearly used it for something very valuable in that case as well. This is Node.js. So Node.js has the ability to execute JavaScript code. WebVI diagrams, when built out, it's a little JavaScript runtime. You can load it up into Node.js. So this is an actual server hosted on Heroku, for those that are familiar. That is a WebVI that's servicing and making HTTP responses. So this UI is a WebVI talking to a WebVI-based Node.js server, if that means anything to someone. All right. This is a Facebook instant app. So all those little games inside of Facebook are actually just web pages. So you can sign up, make a dev account. They actually have APIs for plugging into like your score reporting and whatnot, and to save off like your high scores. So you can make a WebVI hosted in a Facebook app and forget to finish the loading bar API, so that way it's stuck loading. It's fine. You can make a browser extension. So this one, browser extensions are also just little web pages that are running inside of the browser in a panel. So you can wrap up a WebVI, drop in a JSON config file in there. You can make a WebVI that's running inside of a browser, and you get access to the lower level browser APIs. So there's like all these environments that are not supported by NI, but if you're really interested in post stuff in the community, or if there are things that are really valuable environments, please let us know. But these are just more examples. So the first one we talked about, an Electron desktop app. So you could take a WebVI, put it into an Electron app and make desktop applications that will run across platform. You could do Raspberry Pis. So Raspberry Pis can run Node.js. See, these are all things we've like experimented with, but are not like shipping features or anything. But you could do a Cordova app. So that is making a native app that has an HTML UI, and you can call into the low-level JavaScript APIs for a mobile device, and Chromecast dashboards. So this is just a small list that I was able to come up with and things we played with. But yeah, that's kind of the power of JSLI. It's not just talking necessarily just to that JavaScript browser environment, but to whatever host context you're putting a WebVI into. Yeah.
Specifically, just showed just now, the little things, are they on this security?
They are not yet, and it will take a while to get them there. So if there's particular ones you're interested in, because a lot of them will take probably significant work to move beyond like prototype to an example that someone could reuse. But if there's specific ones that you're interested in, let me know. The Chrome browser plugin one? Yeah. Yeah. Okay, I'll keep that in mind. Yeah, I'll look at it. Yeah.
Yeah, a bit of a pain point in LabVIEW is when you want to collect from JSON and then you want to do something with the data that's in there. And yeah, it costs a little bit of time, but you can get there to be able to update a large JavaScript or a large object from a small JSON object, like you might update two things at one time, you want to see down the parameters are not changing. So I had to do some weird thing by putting a control on the front panel that could initially through the JSON object, and it was way more painful than it is in the other language. And I was just wondering if there was some potential for easing into using JSON in a more web-like way in a statically typed language, which is a challenge.
All right, I'll repeat the question. I'm not repeating the questions, that's too long. Go ahead, you answer that one?
That's for you to answer.
For me to answer. When we talked about upgrading the JSON API, and we know there's probably improvements we could make. We haven't yet identified exactly what we want to do, to be honest. We have to update all the platforms that LabVIEW supports if we touch that API. So it's a pretty expensive change. We're only going to do it one time. We're be sure. I'm not sure yet.
In the current gen, you can use the JSON library that has a little better support for that.
Yeah, I ended up wanting to do this thing where I had 50 things in a file, and it's just like it's really tedious going through having to define what's in the JSON object before you can update it, rather than just saying merge this.
In the new gen, you can
Yeah, it's something they did, but it's just about looking at and making my students do this stuff. It seemed like quite an important way to do something about it. Like it's done, I know how to do it, it's just about making it something that's a little easier so you can expose that dynamic. It's thinking more like the web where things are flexible and changing rather than being stuck.
So Okay, so just a quick summarization over the mic. It brought up JKI's JSON toolkit as maybe one option that could help ease the pain. Another one is the JSON text toolkit, which we just added to 2019, promoted in LabVIEW 2019. You download it from VI Package Manager. We don't have anything on the WebVI side, though equivalent to that yet. So we need to figure that out.
Can you change promises?
Can you chain promises? On the JS side, for sure. And then they just show up as nodes on the LabVIEW side. So if you have one function that's returning a promise and another function that's returning a promise, then it's data flow on the LabVIEW side as well.
All right, thanks, y'all.